The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people are evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane Dupont of HawaiiTracker.com, bringing you guys another Hawaiian Volcano Tracker update. Today is Thursday, February 23rd, 2023, and it's been a rainy week on Kilauea, across the island, across the whole state, Dane. That happened at exactly the same time as the volcano went into a big deflationary phase, so the activity on the surface is reduced as well. That's what's playing in the video here in front of us. And we're going to try to untangle it here today. How has your week been? Did you stay unflooded? I won't say dry, but unflooded. Oh, you got us last week when you were on, but this week...
Oh, my bad. Yeah, last week. But down here, yeah, no, the ground had been so porous that it really doesn't accumulate much. I mean, we had some heavy rains one day, but really not that much accumulation on the ground. I mean, even during following the 2018 eruption, where we were getting like a foot of rain a day, it felt like. I'm pretty sure we were getting about that too. It still drained it pretty well.
It's pretty amazing to me, and to people who are not here in Hawaii, like how well the ground can actually drain. Right, this amount of rain anywhere else would be, much more disastrous than it is here. Here, it certainly can be very threatening as well. But yeah, really, a lot of it soaking in. It did affect some of the monitoring signals a little bit. We'll see about that. Whether it affects the volcano is a question that I'm anticipating we're gonna hear today. Yeah. So we'll talk about it a little bit. We won't go into huge depth, because I'd like to maybe follow up with that with some of the researchers at some point, if it's gonna
Right.
be interesting like this. So, but
The interesting thing that me jumping out on it was it reminded me of Hurricane Lane and the end of Fissure 8, where Fissure 8 was going through some really interesting changes, and we could not see it at all because of the hurricane and all the steam and just whiteout conditions. In Hawaii, we call whiteout conditions steam, or at least I do, from steam instead of snow. But similar zero visibility, only catching glimpses of it. And that's kind of what we've been seeing over the past week now, is just, there's something happened at the volcano, but we can't really see it that well even with all these cameras.
Yeah. It reminds a little bit of the beginning of the Mauna Loa eruption too, right? Where it wasn't snow or steam at that point. It was the stormy pattern still, and then obscuring the views and being so remote. Yeah, so it's some interesting things to think about there. Volcanically, it's interesting. Weather-wise, it's interesting. So we'll get into it here today. Dane will be taking questions. We can discuss along the way, leading a discussion in the chat. Let him know if you have any issues with our audio or video. We're still trying to debug some kinks here.
Yeah.
Anything else, Dane, before we jump into it here?
No, I think that's it. We'll get into it, and if anybody has any questions, just drop in the chat, and we'll try and get them in the Q&A that comes up later on.
All right, thanks for that. So let's put this big on the screen here. And this week's Hawaiian Volcano Summary is that the activity on the surface is much reduced. You're seeing here a thermal image of the last 2 weeks of eruption, showing that large outburst, and then here the reduction in activity in the top part of the image there. So that lower right lava body, this is what I call the Western Basin. This has remained fairly constantly steady, although the lava level in here has dropped as well, and it's become fairly sluggish. You can't tell as well because of the speed of the time lapse. But the biggest change is obviously here in the eastern far part of this camera view, where last week we had activity coming from the southern fountain within this eastern lake, switching to the central vent that then poured into and refilled that basin and continued that lake. And both of those sources have shut off this past week here. That's how it visually looks. I plotted for you guys on here. This is the whole last month of precipitation here at the National Park, the Visitor Center on top. And on the bottom, we have the tilt plot from Kilauea Summit for the past month as well. So what you can see here is these are numbers on top of inches per hour, and these are, every bar is 1 hour, so this is how many inches per increment here. So you can see there are several periods of time where you got 1.5 inches, over an inch. In total, the rainfall at the summit of Kilauea was reported by the USGS to be over 1 foot, 0.3 meters. Some of the gauges I've looked at suggest it might be as much as 17 or 18 inches that fell in the area. So a huge amount of water. Likely affected the tilt signal. The tilt signal is what you see here on the bottom, and you see that previously we were having this pattern of minor variations with small deflation inflation events, and even these were causing surface expressions. And when we had the combination of, this is likely a steeper drop right here, combined because of this large amount of water, perhaps. It's not quite clear how these untangle. But after the rain stops, the pattern does continue still, and you see maybe a slightly reduced rate of deflation here, but followed by inflation, deflation, inflation, deflation, and actually, presently, we've started to re-inflate again here, since I made this graph earlier today. So likely some effect of the rain on the monitoring signals, but really, these deflation and inflation cycles are driven by deeper processes in the volcano. We think it's the magma plumbing that's adjusting gas-rich and gas-poor magma, rearranging them within the volcano, so some stuff's going to flush out and be replaced. So you end up having a pattern of more bursts of gas-rich lava, punctuated by pauses or near pauses. And this, in fact, is a pattern that we saw about 1 year ago in the 2021 to 22 eruption. So this is a time lapse from January to March 2022. And what you're seeing here is the last eruption of Kilauea Summit, showing a similar pattern. And maybe let me slow this down a little bit here. So showing a similar pattern as what we might be getting into now, where you see the lava lake circulating and then pausing completely, bursting forward with a large expansive eruption and then pausing again. Sometimes not fully pausing, but just reducing its activity and dropping its lava level within the pit there. So that is the summary of Kilauea. And for Mauna Loa, we'll just share this image from Raymond Nayert to Hawaii Tracker. That's showing an image of the steam coming from a Mauna Loa lava flow, taken from an image in the Saddle Road there. So that sums up the activity on our volcanoes for this past week. And that said, we'll jump into the details now, starting with Kilauea. And let's put Kilauea on the screen here first. And let me adjust my title here, and we'll talk about our observations of Kilauea here. And we'll start off today with this S1 camera. And the S1 camera is going to show you what it actually looked like day and night here. So you see the lava coming from the central vent, pouring into that eastern basin, and you see a whole bunch of clouds come in. The rain is flying by, you don't see a whole lot, there's a whole bunch of steaming. When it finally clears, you see a couple glows within that eastern basin, a whole lot of steam, and no more lava. You see some of the spots of glow and maybe little small bits of lava in there, but for the large part, this camera focused on that eastern basin is really showing the most dramatic part of this change over this last week. So that's the S1. The nice views this past week come from the KW camera. It's got this wider angle view, so there you see that's similar to the thermal that we started off with today, but daytime, nighttime, showing all the steam. And it shows why that thermal image is so useful, looking through all this weather when it occurs like this. Even it sometimes gets blown out by how much water's in the air. We've actually cleaned these time lapses a fair bit to show you guys what's actually going on here. This one is in this pure form here, showing all the frames day and night, all the steam, a little bit of glow at night, visible through the steam, a smaller area than before, but still there. You do see some couple other spots of incandescence coming from around the edge of the crater, so that was noteworthy that I'll point out here in a minute. So let's start off with, from there going on to the thermal image of that view, and this is looping here, so this is sped up. So let me slow this down a bit too. And there is that start of the sequence. You can see that little bit of lava that was oozing out near that central vent last week. That was short-lived, and right afterwards is when you see the reduction in lava levels. Focus here back on that eastern lake first. There is that little outburst. You see the central vent died off, and here's we have the two spots, one in the north part of that eastern basin and one in the south part where that fountain used to be. And these are the two areas that we suspected, given the previous reductions during deflation and inflations, were putting out lava. So all three of these outlets over here, these three vents, 1, 2, and 3, have all shut off. We expect temporarily. The USGS is saying that when deflation level, the tilt level is returned to its previous pre-deflation levels, the lava is expected to resume and return. So focusing more on that western basin here at the bottom, you can see it also has had a continual reduction in activity. It's harder to see an overall pattern, but one thing you might notice is that we're changing from having this larger shape that was more like this, right, to now it's becoming more of an oval that is like that. And so the way this is happening, as we had over the last couple months, this little peninsula on the south side grow out. And really over the last 10 days, week and a half or so, this northern peninsula started to grow out as well. And so it seems like this is also a result of that dropping lava level. So what's interesting, because previously this whole area was created by the eruption from the west vent, which was over here. It would come down through a lava tube to this west vent pond somewhere over here, and then through another lava tube that kind of went off in this direction. Lava came into this pit and then split into three. One drain back beneath the crust was over here, one was over here, and one was through this little lava tube to the southern pit, which is no longer glowing anymore in the last week over here. So since the eruption returned in 2023, lava has reversed this direction, now coming out from this northeast former sink area, and now has become the inlet of the pit. And it seems like the lava likely is making use of that previous sink there, but also perhaps it's, given what we saw last week, this continual flashing over here, it may also be using this other pathway that goes over here to the southeast. And what seems less true is that this previous entry point of the west vent into the lava lake seems to be isolated now, right? So it seems like this maybe is getting cut off. These two peninsulas are gonna likely merge here, create this little septum, and divide this western pit into two different areas, right? This continual area with lava input in the east, and perhaps an area that gets lava less frequently now that it's building this little division here. And you can see that by the end of the sequence here, how really this bottom part, this westernmost part of the lava lake is showing less of this bright color here. Now the color does flicker a bit. I'm not using every single image. I had to take out all the really bad rain times, right? So it's just to put that caveat in there. There's a little bit of magic happening here to make this actually viewable for you guys. So a couple other things that are not as evident, but there's a couple of spots down in here. There's a little ooze up flow. It seems like there's another spot. I don't think it comes in quite yet, but there've been a couple little spots that seem to be still oozing very, very slightly, and this is just likely some minor effects of the whole adjustment of the crust to the changing pressure below it there. So that is the F1 observations this past week. And I thought I'd switch now to our V1 camera, and this one is also cleaned to give you a better idea of what's actually happening with an event. And this is obviously very sped up as well, but what you can see is there's the input in the northeast. And what you can see, as I loop this around here, is that it starts off more continuously, and then it starts actually pulsing. You see the lava crusting over, and then a pulse is coming from this area, spreading across the lake. Occasionally you see an overturn that is induced from one of the other parts of the lava lake. But really it's really stagnating within this western pit. However, it does seem to still be circulating within there. So this is the only active lava still present at the surface of the volcano during this lowest part of the deflation here. So we will await to see whether this is the only spot that remains active after lava returns. It seems like it depends on how long it takes, really. The vents can harden, they can in some ways kind of clog up, can make it not as easy to come out, but at the same time, you have gas accumulation under the surface. That's what's causing this big outbursts come out and lava to be put along the surface in all these areas. So whatever little, I don't know, call it coagulation or gunking up of that nozzle here at the surface, if you get a big enough gas burst coming through, it'll just clear it all out and resume its previous activity. So that is the V1, and switching now to the B1 camera as the last camera we have. Now this is looking from the east further west, so further view of the lava activity, but perhaps a more honest view of what the viewing might be like this past week here. So depending on when you come, you might have actually seen nothing but steam, fog, rain cloud, or you might have had a clearing and seen the crater floor with all of its steam rising from that really hot surface, which I think is something worth highlighting. We'll talk about that more a little bit here in a few minutes. So it's less about the lava this week is really what it comes down to. The viewing hasn't been as good this week, obviously, because between the rain and the reduced activity. However, you can see a lot of stuff in the park all the time, even without lava, and I looking at this for so many years now, I can appreciate the different views of the steam on a lava lake here, and I'll share that with you guys. But to kind of make sure we're covering our viewing, let's load the live stream here. And this is from a little earlier. Let me give it a refresh and see our current peek into the pit. And since my refresh, it's now back to white out down there. And peruse the Summit webcam cams again, just to see what you might see. Something like that. There's a KW camera. A little glimpse through that mist. There's our F1 camera showing pretty similar activity, still only within that western basin. It looks a little more active now as the volcano is re-inflating, but still nothing coming from the backside. And perhaps because we haven't reached the threshold of magnitude yet, it hasn't inflated enough to burst out again. We'll have to wait and see. And otherwise, let's look at whiteout and 3D steaming. There's not much else to see here on these cameras. So I do want to mention, as we talk about lava viewing, the national park does maintain their website, and you can see they've got an updated message here. volcanic activity within Hale Magma crater has significantly diminished as of February 22nd, 2023. The lava viewing is limited at this time. Conditions can change anytime. Check the updates. Still delays and limited parking due to high visitation, so check all that, all the different sites, and if you're planning to come because this is the only time you have, then you can make sure you're up to date with the current status of the park here. And of course, there's the viewing map showing the various areas you can see from, right? And we've highlighted in the past Kilauea Overlook, that's over here, Upinai Ipali over here, and Kanakakoi Overlook here in the south. But I won't go through any of the views today from those places. What I'll do instead is show you guys the KW camera here. Let me loop this here. And what I've done is take out the nighttime images. This is just the daytime views of that camera, just so you can accentuate the steam here. I think it's really pretty magnificent to see that whole crater floor hot and steaming like that, right? That's one thing I always enjoyed when I was guiding on Kilauea, is every day is a little different to see, even if it's a pattern of the steam. Every day reveals where the ground is actually hot. We released a video a few months ago showing the thermal scan, how that whole area beneath that crust is very hot, but it's something else to see it yourself with your own eyes and see the whole thing steaming, right? If you can catch a glimpse here in between. So I thought that was worth highlighting for you guys there. And let's see, there's one other thing that did not get put in here. And let me throw that up in here as well. Next here. So thanks to Two Pineapples, Lou of Two Pineapples, we did have a capture of the USGS moving their V1 camera during this intermittent break in the rain, and after that reduction in lava volume. So here's that southern fountain area of that eastern lake, and we're kind of panning across the eastern lake, looking at all that jumble of mess that's in there. And after the lava drained away, you see all this topography, all this exposed cliffs, and it's hard to tell right here what was what, right? But this is these flat top surfaces. This used to be that floating island, that peninsula that was getting wedged across from that lava lake. And cool to see the different view of steam here, I think, as well. I can see that snapshot and kind of real time there of what that area looked like. Still a little bit of lava oozing. You can see a little spot right there. That pretty cool view of the conditions here, something different that we don't usually get to see, right? And that's something that I can appreciate here. All right, so I'll stop that there. It's pretty cool. There's more of that on Two Pineapples YouTube channel if you'd like to see the rest of that video. Otherwise, I will move on to our air quality and gas report here, and that's because that's our main volcanic hazard of this eruption, is still the gas. This past week, not so much, because the rain has washed a lot of it out. Secondarily, when a volcano is putting out less lava, it also puts out less gas. So the combination of less gas coming out and all this moisture through the air has made it pretty VOG-free a few days here. So, of course, no one's worried about the VOG when they're worried about the rainfall. So it's kind of one or the other here. But in any case, air quality in the park has all been in the green. I won't really dwell on this too much here. I will show this loop of the VOG mapping project for the next couple of days here, showing what is expected as far as distribution of SO2 from Kilauea. I can zoom it in a bit here. And mostly for the next week here, we're back to our trade winds, and so it's all blowing to the southwest from Kilauea and affecting these areas of South Hawaii, perhaps Pahala, Ocean View areas through here. Right? It doesn't seem to be quite towards the coast in the next couple of days, but within the next week, who knows here, it's still putting out gas. And once the lava does return, it may put out a big burst of gas, and that might be when, if the air is clear, you actually can smell it in the downwind communities here. So that's still the primary hazard. Usual precautions still apply, but it's not anything new, and in fact, it's a little better than previous weeks. So that is the VOG forecast, and here is a capture from Purple Air from about an hour ago, showing mostly green all across the island here. So everyone's air monitor is in the clear as a result of all this cleansing of the air from water. right, so that's the gas. Let's go into the monitoring signals now. The monitoring signals are where it gets a little interesting for us to untangle a little bit here. So, Kilauea monitoring. So we'll step through our usual graphs. I want to talk about how the weather is affecting many of them. First up here is our 1 week plots of summit lava depth at the top and tilt at the bottom here. The lava depth plot is pretty useless at this point. Our scale here is going from 520 meters to 380 meters, so it's got a 140 meter, 500 feet difference there, right? And so that's not the distance of lava moving up and down, it's a distance from the laser rangefinder down to the lava lake. And so when the fog gets right in front of the laser, it thinks, oh, the lava's right here, right in front of me. And it puts up one of these higher values. So you have to ignore all of that, and really the changes we'd want to see are all buried in this flat line in here, which is the real data. And if we were to filter out all this extra rain measurements and zoom it way in, you might then be able to see the little variations in the lava level. Then you could see if you had small drops or anything related to the rain. But with the current information here, we don't have that ability to look at that. We'll talk about some rain effects here in a minute. But to look at the tilt here, this is a tilt for the last week, and the tilt was still at a steady high, and it's really in the morning of the 17th when it begins that drop. See a little faster at first. There's a little bit of an inflection point right here, and this is where it's not clear if that's the changing effect of the rainfall, or if perhaps there is some other fundamental change underground that slowed that rate of deflation, and the rainfall is more of a consistent presence across more of the signal. That's really unclear here. It's hard to really untangle that, and there's no real answer, to be honest, there. We can just talk it through with some of the examples that we have, and I'll get into that a bit here when we bring up those precipitation graphs once again. Looking at the last month, our last month of data for depth has the same issue with the noise over here. It is, if I zoom it in enough, you can see there's a little bit of an increasing line there, but it's still not enough that you could actually make any conclusions or inferences from. But it does show you where the bulk of this activity happened, right? And you can see that pretty directly correlates to that timing of when the deflation started as well. So that's coincident in timing, bad luck, good luck, depending on how you think of it there. But there's certainly a combined effect there going on. Now, what's interesting is if we scroll down here to the East Rift Zone tilt at Pu'o'o, now we're looking at two different components. That one that's the blue one that's more directed at the rift zone, and then the green one that's more tangential. So really the blue one is what's showing that rift zone response to the rainfall here. And one thing we've noted in the past, and without digging it all out, is we've noted in the past that when we have big rain events at Uikahuna, the tilt signal seems to go down with extra rain. And at Pu'o'o, it seems to go up with extra rain. Right? That's just something we've noted ever since 2018. Just the configuration of where the instruments are placed and related to the rift zones and the areas that collect that mass of water. So here at Pu'o'o, you can see the pattern, and I'll maybe zoom it in a little bit. I will point out here, there was that earthquake we talked about last week, that Dipahala earthquake. That's not related to the surface, but it's shown up here as this little jog in the data right there at the summit. At Pu'o'o, that earthquake did seem to have a little bit of an offset, right? So something shifted and kind of either tilted in or just wiggled somehow and stayed wiggled. And there may have been some more adjustments happening, but really the rain events are what you see here, these double peaks right here. That is purely the rainfall, it looks like, right? That when you see these really jagged edges here, that's more of that rainfall pattern, as opposed to when you're looking at, say, these deflation inflation signals. You see those nice smooth curves there, right? Really different looking pattern there. So this is what a rain signal actually can look like, right? Combined with some settling effects in there as well, right? And so there's a scale of these. In the case of Pu'o'o, it all depends on the instrument location and setup and all of that, right? But in the case of Pu'o'o, you're looking at it actually can do something like a 2 microradian excursion there, perhaps, right? And so if you imagine up here the summit tilt plot and just as a guess, and totally arbitrary guess that's not likely to be right. But if we were to put 2 microradians in here, that's that much, right? So you might consider that maybe that much of it might have been the rain, and then the rest of it, this signal, at least, or possibly, right, could be the actual true indication right there. So if you can connect that and kind of go backwards, that might be how it actually looks, right? So even still, the deflation that's come back up, the inflation that's come up since the deflation here has not reached that prior higher level. And maybe that's why, even though we're seeing various episodes of inflation, deflation, it hasn't actually reoccupied any of that. So we look here on the right, we see inflation occurring again now. How high will it come? That's an interesting question, right? It could come up higher as well. And we'll have to see just how it works out for the next week, how much effect was actually the rain, at what point a tilt level return actually causes a surface effect, and all of that, right? It's really impossible to tell now. But one thing that is in back of my mind as well is you have all accumulation of water during this phase in here, but then it actually, over time, is going to produce the opposite effect as it all drains away or moves, and the ground can then rebound from that. So overall, if we're just talking about the rain effects on tilt, you might see something like it actually going down, and then it might slowly come back up to restore its level, right? Assuming there's no wiggling and adjustments in between there. So that's embedded in this plot here. So just seeing this rising levels is interesting, but might not be volcanic. It might be the combined effect once again. Hard to tell. We'll have a better idea of what actually did happen when we can look a week from now and see how it all played out, and maybe talk about these thresholds once again. But for now, since there's so much hand waving and just guessing what might happen there, we'll move on. And
yeah. I was
thinking about more of this. Go ahead.
I was thinking about that. The period, because we know about the rain bumps, right? But the period of them draining away, right? In the water basically going down into the, starting the water table descent. We know that process is very long, but the surface level should be relatively quick. So I'm just like, what are we talking? Like days to weeks, weeks to months, months to years?
Couple days.
Couple days, you're thinking?
Couple days, yeah. Something like that. Days, right. Definitely not weeks, definitely not months or years.
Yeah.
And I forget, I have to pull out some of those groundwater studies from before, yeah, but I think that's the last time I looked into this was a couple of days was the answer there.
Right.
So yeah, it should, by next week it should have kind of cleared out, unless it really doesn't stop raining and the ground stays saturated the entire time and it can't actually adjust.
Which it might. I mean, it might.
Yeah, but I will throw in there's an extra X factor is you do have all that really hot lava there at the surface, a huge amount of it. And if anything can reduce the effect of all that water and get it out of there faster, it's a whole bunch of heat, right? So I would expect it to be a short-lived effect. We'll have to wait and see, obviously. There's always steam because the groundwater is always trying to get in there, and the volcano is always kind of battling it back, burning it off, right? So it's just a little bit extra of that now, and curious to see how that plays out there. So that's the tilt plots for now. I'll put them with a precip here in a minute. But to cover our bases, here's earthquakes. Pretty steady levels, not a whole lot of change. A couple of variations in here, but that's all normal. Nothing really to speak of. No new SO2 measurement. Obviously, the weather has prevented that from occurring. So previous downward trend still seems to exist loosely with some variations in between there. I threw this in here. This is the actual Sand Hill SO2 data plot, and this is subject to the wind direction as well. And we did have some changing wind there, but just as another peek at how much SO2 is coming out of the summit here, you can actually look at this plot, and between the change in the wind direction and a possible reduction in output, you see a drop in the SO2 here recently as well. Okay, for the last year, looking at the last year timescale, earthquakes, here's our build up to the adjustment of Mauna Loa, build up to this most recent phase of Kilauea. And that's where it starts in the gas with its spike, and coming down, there's that long-term pattern with that small variation you see being that much in there right there. So still following all the patterns, no surprises there. GPS in the summit is something that takes a few days to come in, so we're not quite sure how this weather might affect the data here. But we did note how when the eruption began, it's had a downward trend, a deflationary trend, as the north and south edges of the caldera came closer together. seemed like it was pretty flat here for the last week, and now we're getting some wiggles here at the end, and we'll have to wait for this to clear up between the noise and filtering and all of that. Right, so I don't see anything on that, but it does seem to, you don't see any big jumps in any direction, so suggesting to us everything is still behaving as it was before deep underground. There is the East Rift Zone line showing the same pattern, no change there as well. So deep underground where the volcanic pressures are what's driving all this activity, there's really not any huge change. We're really seeing changes on the surface as far as how lava is coming out and maybe bursting out with a gas release there to cause the deflation inflation cycles. So that is the monitoring signals. I can show the earthquake maps for Kilauea. Not a whole lot really there, but I can flash them on south flank activity going on through here. Summit, Pahala earthquakes still going on as well. Okay, so what I wanted to share is that the National Park Service does have the live weather and air quality data, so it's mostly air quality here. But you can select your park, and I've selected Hawaii Volcanoes National Park. And you can come in here and it gives you all kinds of stats, all kinds of recent data. What I've pulled up here is a precipitation for the last 7 days at the visitor center at Hawaii Volcanoes National Park. Now, it's not as good as having a rain gauge right at Wikahuna at the former Jagger Museum. I'm not sure what that data is. Maybe that's the 1 foot that USGS is reporting. But otherwise, what we can see on the public side here, this is another closest station, and it's only a couple miles away. But across those couple miles, there's a pretty drastic variation in climate, and that's accentuated when you have these more subtle weather patterns like the trade winds and all that. But when you have these huge storms, it kind of gets everywhere all at once. And so I'm hoping that in this case that this site's close enough, and this is where we're pulling this rainfall data from. So you can see there it really begins. The highest value we have early on was on the 17th at 8 a.m., 1.33 inches per hour. But since then, you can see it's been low levels of rain there, and not a whole lot of that same caliber, really. So it was really that initial burst here, right, that occurred 17th, and this is the 18th here at, what is this, 12 p.m. noon, right? So kind of from 17th through the midday of the 18th here was that largest period of effect. So taking this, this is showing inches per hour. We have the USGS report of that 1 foot. What I did is come here to the weather underground. Let me make this bigger for you guys. And picked out a station here. There are several stations in this volcano area up here. Here is the actual station I chose. They're all fairly similar. Here is Hale Ma'u right in here, and not too far away. And here's an outline of Kilauea caldera if you can't see it, and Hale Ma'u crater right in there. So I did this to come down here because I wanted to come down and look at the actual graph of total accumulation precipitation, which is this plot right here. So here we have our value is the blue line as accumulation. So this is showing at that site 7.64 inches. In that first burst, the instrument resets. And the second one, 9.4 inches right here. I wonder if I can make that bigger. 9.4 inches there. And 7.64 there. So together, that adds to 17 inches of rain at this one station. And obviously, there can be variability. But just as an example of how much water actually fell on the ground, if you're wondering, like, oh, can it really have that effect on the tilt, or how much effect could it actually have? Could it change the eruption? And so the first thing is how much water, and there was a huge amount of it there. I wanted to share that station with you guys. And coming back to this is our plot of the tilt for the month, side by side with the precipitation at the visitor center. And now I've taken back the whole last month. So most of the last month was pretty dry, a couple little bursts here. But really, it was, there was actually one burst in a week of the previous week, right around Valentine's Day there. And then here's the more recent burst we're looking at within the last week here. So looking at that section, it may be more obvious how this really lines up here, right? The rainfall kind of starts in here, and maybe you're starting to see some effect, and the deflation starts on its own. This abrupt drop seems like it's the typical volcanically caused signal. but the rate at which it's going down may be affected by this accumulating rain right through here, right? That's really what I wanted to point out here. If we look in more detail at just the last week, here it is more zoomed in. There is the actual start of the drop right there, and pretty coincident with the high peaks of rain. And why it's not clear, you can look at this peak of rain over here that comes afterwards, and you're not seeing the same effect down here. So that's really curious whether, that's really like an overall long-term effect that's affecting the whole signal all the way to here, or whether this might be some adjustment of the water, or this could just as easily be a true volcanic effect, but the whole thing being skewed and offset, kind of stretched out rather than the original scale it would be because of the water as well. So not quite clear, but overall the signal does appear to be that typical volcanically driven process, right? And we'll throw one more up here. And so this is the last month once again, and so the top is the same, and I've done something tricky here. I've taken a Pu'o'o tilt meter and I've flipped it upside down so it look at the same orientation of movement as the summit here, right? So this might be what the actual rain signal might look like, more or less. It's not the same location. It's separated by quite a bit more distance than that station I just showed. But you could see the comparison, right, of where we know there is no lava coming out and there's no activity happening there. There's adjustment of the ground certainly still happening. That's what that looks like. And up here, this is what it looks like at the summit. Right? So you can see that the nature of the lines being a little more wiggly as a character of the rain, but you can see the actual scale and pattern of it as well. And so while I can't untangle it exactly, I can show it to you guys like this and have you just observe that coexistence of all those signals there at that same period of time. So there's a couple of things that I wanted to mention as far as the rain effect, right? One is there has been research put out that perhaps the 2018 eruption was triggered by rainfall. However, I thought I'd just briefly highlight today the response article by the USGS team, led by Dr. Mike Pulland. This came out in February 2022, just about a year ago. And this is a response to a previous article that did suggest rainfall was an eruption, and there were corrections and responses and all that, but I won't go through all of that. I just want to highlight a couple of the statements in this. This is a publisher preview from Nature Research of this full text article. So this is only the first page is available for free here, but I'll just highlight from here what there actually is, right? So let's see here. I might need to go get my glasses here soon so I can read all this stuff here. Let's see, I'll pick out the ones that I wanted to share for you guys. So we argue that Kilauea's 2018 eruption was caused by significant pre-eruptive pressurization, and that pre-eruptive rainfall was not extreme, and that there is no significant correlation between rain and eruptions at Kilauea. Right, that's the key thing there. No significant correlation between rain and eruptions at Kilauea. I'm going to jump over here now and highlight this paragraph. Lava lake surface elevation changes provide a near direct indication of change in magma reservoir pressure at Kilauea. So really the lava lake level is a better indicator of pressure than anything else, right? In 2018, the pre-eruptive weeks-long increases in lava lake surface heights at both the summit and pool imply pressure changes of hundreds of kilopascals that affect the entire magmatic system of the volcano. Hundreds of kilopascals, right? The unit's maybe not important to you guys, but it's in the hundreds. So these pressures increase transfer stress to the volcanic edifice, as indicated by geodetic data. The pressure changes exceeded by more than 2 orders of magnitude the rainfall-induced pore pressure perturbation of 0.1 kilopascals, modeled by Farquharson and Amelung at a few kilometers depth, which itself is smaller than changes induced by the Earth tides of about 10 kilopascals. Thus, stress changes over both short hours and long weeks to months timescales far exceeded those modeled as due to pore pressure variations. So further, groundwater near magma probably exists in a highly compressible, multi-phase liquid and steam or supercritical state, which would further reduce the very small pressure changes modeled by the authors. Right? So I won't read any more of that, right? But the bottom line is you're looking at something of the scale of Earth tides, right? Even smaller than the Earth tides. So if the volcano is ready to do something, then these little changes could actually set it off. It's a huge amount of water for us, but compared to the forces of the gas pressure and the magma moving underground, it's pretty insignificant, right? You're talking about like 0.1 as opposed to hundreds on a scale there of effect. So it can have an effect, but it's not likely driving full-blown eruptions deep within the magma chambers further down. However, there is research. I don't have any kind of article to show for this, and this was something that I was able to watch at the AGU presentations the year before last, at the end of 2021. And in that, Dr. Matt Patrick was describing how they did see that cloudbursts with very heavy rainfall actually induce spattering on the surface of the lava lake. Right? So there's the lava lake has its crust, and then when it's raining really hard, you see that crust actually open up more. You see more areas where it's spattering. When the rain stops, it kind of goes back to its regular activity. He was actually talking about the lava lake depth, and using a laser rangefinder, they'd actually detect the lava level would drop by perhaps up to a meter, 3 feet, a yard or so, as a result of that extra gas being vented out. And that's something we see during this passive overturning, these crustal overturning phases of the volcano as well. And if we could zoom into that depth right now, we might be seeing that on our depth plot showing the overturning pressures there. So rain can have an effect on the lava lake, but it's a top-down effect, right? It's something like where the lava lake has some surface configuration, and top-down, maybe you punch a hole through that crust of the lake and allow gas to escape, right? People used to, in the 60s and 70s, throw rocks into the lava lakes and actually induce these gassing outbursts. So we know that happens, and if you can do it with a rock, why not with a huge volume of water that happens to dump in and break the surface of the crust? So it can have an effect, top-down effect, but it's also very minimal to that surface, right? Could it cause things to crust over, potentially, in a small area? Maybe so. But it's not going to cause them to drain out by 30 feet or more. So that draining effect is fully the actual volcano doing its thing. Just happened to be coincident with this to bring up this whole discussion once again of the rain and how the rain is affected. So I'm not saying that rainfall doesn't have any effect. It certainly has effects, but you have to consider the magnitude of those effects, right? What it actually can do. It can actually change the surface configuration, like the nozzles, that kind of stuff. But it can't change the fundamental organization of gas and magma within the volcano underground that's driving all of this, and it's hundreds of times stronger than the force of that water and of the tides. So hopefully I've been clear enough with that, and I won't go any further just to confuse it.
I just want to do a little side point if I can on that.
Yeah.
Just about, living in Leilani, living on the rift zone. One of the things that I always that immediately jumped to me when I first saw this paper and this research about the rain inducing the 2018 eruption was, okay, where are your measurement points, right? Because this isn't like the mainland where you can go put out a rain gauge and it will be accurate for several miles around. No, there is 50 or more, maybe up to 100 inches of difference of rain annually between one spot in Leilani Estates and just a couple miles away in Leilani. And we're talking about 20 miles stretching all the way with similar, highly variable rains between here and the summit. So where was the measurements? Like, and they were using satellite observations, I think. Wasn't that it?
Yeah.
And it was just immediately was a red flag. Just the rainfall that you're saying. I don't know if you're if it's actually saying what you think it is, because I've been on the ground in Leilani and watched it. The reality disagree with whatever predictions or observations that were supposed to be happening. Just errors and things like that happen.
Yeah, for sure. Yeah. Yeah, I can certainly second that. I live here kind of not exactly in between, but somewhat equidistant from the summit and Pu'o'o. And I've noted for many years the difference in the signals from one spot to the other, because it'll rain a huge amount in one spot and not in the other, and it can be either one of them. And I'll kind of leave it at that. I mean, like I said, I don't want to dive too far into this paper, because there's a whole laundry list of things, and there's corrections and responses, and so all of that. Like, you know, let's we don't have to dive into the actual study itself, right? Yeah, the actual scientific process. Yeah, but like, you know, let's just focus today on this paper. This not really paper, so actual response, and I will try to get more on this, and I would like to have more information, maybe from the authors themselves, to present it fairly, right? If we're gonna do something like that. In any case, not likely the cause of this current activity. Maybe could cause some activity like on the surface of the lake, but it's really not something we're likely to see here with the challenges of the weather here this past week. What is likely is that we're returning to this pattern that we saw 1 year ago. So this is, once again, January to March of 2022. And let me slow this one down once again too for you guys. And you might note here that there are times when, it's going to start over here. The lava lake is a little larger, it goes all the way drained, bursts out, drains all the way, bursts out, drains again, bursts out, drains again, bursts out, drains again. Eventually it comes in a steady pattern where it starts circulating what we saw most of the rest of last year. But there was this 2-month phase here, right, where even during the Volcano Awareness Month last year, right, we have a statement said that any one of these big pauses might be the last one, and eruption might actually stop. And that's certainly on the table still today. Like, you know, it could be that actually the surface nozzle actually gets clogged in some way where it can still inject beneath the crust or adapt in some other way. But it didn't, in fact, end after that. That was actually turned out to be just a stage of the whole process of the eruption, right? It kind of went through that first burst out phase where it put out most of its lava, most of that covered the whole crater floor, and started retreating back to its lowest spot. And once that happened, I started going through this bursts and pause and bursts and pause and bursts and pause. And finally, it went to that steady state of continuous circulating all the time. So I would propose that what's happening now is the start of this burst and pause phase of this eruption, just like we saw last year. Right? That seems much more likely. This was something that last year lasted months, more than one single weather event, and you can see the process went on, and I suspect we'll see this going on longer than the weather here. We'll see this maybe this week and next week, and possibly beyond that as well. So I think that's the best analog we have right here. And just to kind of put it together, here is that a clip from that Volcano Awareness Month from last year, when 1 year ago they were saying activity is on again, off again. It's currently pausing during larger deflation-inflation events. And at the time, this is what the tilt graph actually looked like, right? And as you can see, it's got lots of deflation-inflation events. Some of them are back-to-back. Some of them have that V shape stacked on another, and some of them have more of these U-shaped with kind of inverted V's here in between. And this red line was a theoretical threshold where when deflation dropped below that level, then the whole eruption paused entirely. So we haven't seen the whole thing stop all the way like that yet, but we might be looking at something similar coming up too. We'll have to wait and see. But if anyone's wondering about the tilt pattern now, this is what it looked like a year ago, a little more than a year ago here, a year and 3 months ago, and showing that relationship a little bit. So that seems the most reasonable outlook at this point. I did want to credit the USGS here for all our updates, and they've put in some more detail this past week. I'm only going to highlight a couple of days here. I'm going to start off with Sunday, the 19th, when they actually put in more of this information. And at that point in time, they say, summit eruption in Kilauea within Halema'ama'u crater is greatly diminished over the past 24 hours. No significant changes in the rift zone, and everything is still confined to the crater. They noted eruption of lava in 3 locations on Halema'ama'u crater floor is greatly diminished over the past 24 hours. The 3 locations, by the way, the western basin that's still active now, the central vent that was productive last week, and that eastern lake that was also active last week. The eastern lake and central lakes are no longer erupting. The western lake and the basin of the 2021-2022 lava lake remains active, but at greatly reduced level. Very little lava circulating within the lake, which is mostly crusted over with intermittent crustal overturns. The reduction activities related to a larger deflationary tilt drop that began in the early morning of February 17th. Activity in the eastern and central lakes began to diminish in the late afternoon of February 17th, and both were inactive on the 18th. Activity at the western lake diminished throughout the past 24 hours, and the lake is now mostly crusted over and down about 10 meters, 30 feet or so. Surface eruptive activity is expected to resume when the summit re-inflates to the level preceding this strong deflation. And I just throw my own caveat here, minus whatever rain effect is in there, right? They note the scale of the deflation there. Here is where they say there has been about 1 foot, 0.3 meters of rain during the last 48 hours, creating intermittent whiteouts that obscure the cameras. Tremor remains in the background, SO2 from the previous week there. So that was an update on Sunday that really put in all this information. There's been some repeat of that in the last few days. So I thought I'd just tie it all up with the update from today, which notes some eruption of Kilauea within high mountain continues to be greatly diminished over the past 3 days. Other changes here. Let's see here. There's really nothing new, honestly, in here, right? Western Lake is active, weak lava flows, very little lava circulating, mostly crusted over with intermittent crust overturns. Reduction related to larger tilt drop, expected to resume when it re-inflates the levels observed in the prior week. And so that is basically it. No other changes to report, but that's just the update for today. So with that, we'll switch over to earthquakes here. And not a whole lot to talk about as far as earthquakes either. No large ones this past week. The largest was a 3.2, which was actually here at Honamu. Very deep, one of these settling adjustment earthquakes of the volcano, which we'll cover some other time. Otherwise, almost nothing around Mauna Loa. Very little around Kilauea, and Pahala is still doing its thing, although it seems like a little less normal as well. So really not a whole lot to report there on earthquakes. Everything's normal. There's really no point in belaboring that any further. But what we will do is talking about earthquakes, switch over to this week's Volcano Watch article, which is titled The Missing Slow Slip Events on Kilauea's South Flank. And what this is posted on HawaiiTracker.com, but this is actually describing the difference in the South Flank movement prior to 2018 to after 2018. So here's prior. We had these slow slip events, SSEs, which are when the ground is moving along a fault line, but it's not doing it in one big jerk and causing an earthquake that lasts only a few seconds. It might be doing that over the course of 24 hours, and it's moving that same amount, but it's doing it without the shaking. So slow slip event, geologically it's still pretty fast within 1 day, but it's not within a few minutes where it's causing all that shaking and all that. And before 2018, these were occurring about every 3 years, plus or minus a few months. There had been one prior to that in 2015, in 2012, and there was one expected in 2018 as well. However, quite likely, because of that 6.9 earthquake that occurred, actually moving this area of the fault as well, it essentially reset itself, right? So instead of having, so these two scales are the same. I really appreciate that. Hello, USGS. So you can compare these plots 1 to 1, and you can see it's a similar amount of drop here, right? But we actually have maybe a little bit more gradual and then a little event, and a little more gradual and an event. Whereas here we're actually seeing it be a little more continuous and a little steeper. And then here at the bottom, right in here, you start to see this little curve where it's starting to shallow out a little bit. So maybe we're finally recovering from that 6.9 earthquake to where you might start seeing these SSE, slow slip events, occurring in the future once again at some point. But so far, what you can say is the South Flank is still recovering from that 6.9 earthquake that occurred in 2018. Right? The article is interesting. I could kind of go into more detail here. I maybe highlight a couple of things. Like they talk about how the areas, different parts of that fault behave differently. Some are stickier than others. Some are more slippery than others, so they actually will slide without earthquakes. That's your slow slip zone, whereas the area that actually has sticking, and that's the part that's going to break and cause a big earthquakes. So the 6.9 earthquake was big enough that it actually started at the area where it actually breaks, but it was so large it spread out across the entire flank, including the area that actually normally just slides past one another. So that's why you have this change in behavior. Seems likely that they've got this right. Let's see here. They give a couple examples of ways that you can imagine how these faults might move differently, right? Like where if you have an area that's actually better off just kind of sliding slowly, if it tries to move too fast, it actually gets more resistance, and so it doesn't actually allow that to happen. And they put out the analogy of trying to wade through water or something, right? Like you can't just like full-on sprint through water, like the water is going to push back so hard. You can actually, there's an optimal speed where you can move just fast enough to actually make some progress and not have the water knocking you off balance and pushing back on you, all that. That's the one kind of process. On the other hand, they say that they're using these terms of velocity strengthening, velocity weakening. I was trying to get past that because I think that's a little confusing here. But in areas where you have the faults actually breaking and moving, that's like trying to drag a box out from drag a big box across the floor, right? Where it starts off kind of stuck, but once you start moving it, you can start sliding more freely. So that's the summary I'll make of the Volcano Watch this week. For the full article and more details on that, you can go read that article on hawaiitracker.com. Anything you want to add here, Dane, before I jump into last week's Volcano Watch?
Yeah, just on this Volcano Watch real quick, and you get out ahead of something that I just know how the internet works, and this is not the Helena slump that's being talked about here, right? We're talking about the South Flank, which is a larger feature, a significantly larger feature, and deeper feature than the Helena slump. Just get ahead of it a little bit. Because I know some people are going to do that. They're going to see this and be like, oh, it's Helena slump. No. I've seen people even post pictures like, oh, look at the Helena slumps. Like, no, that's South Flank, guys.
Yeah, it's a little confusing because some people refer to the whole South Flank as a Helena slump, which is not. The South Flank is what we should call it, right? The Helena slump is like one small piece of it that's largely misunderstood.
Largely, yeah.
Because this whole South Flank is a critical part of Kilauea's eruptive process. It's always moving all the time to allow the volcano to kind of grow, and that's true for hundreds and hundreds of years. Yeah, longer, thousands of years.
Right. If you've been watching us for a while, for a couple of years now, we've been talking about the South Flank, a long time, and saying like the South Flank is driving the car, right? Not only on Kilauea, but we've even gone so far to say like it's influencing Mauna Loa too, the South Flank of Kilauea.
Yeah,
it's driving the car in large part.
Yeah, and Kilauea is a South Flank of Mauna Loa, right? So it's like kind of all. It's like you have two South Flanks stacked, right? That's the level we've taken it to. It's not a slump. It's a South Flank. There's two South Flanks stacked with two interacting volcanoes, and so it's an important piece, and it's more nuanced than that. It's pretty lazy to just say, oh, that's the big thing that's going to be the next catastrophe. We should all look at that. Come look at my video, right? That's really lame. Yeah. Okay, so this
internet for you.
yeah. Some parts can be lame, and some parts can be awesome, as obviously we are. Yeah. So last week's Volcano Watch, comparing crises, Mauna Loa 84, Mauna Loa 2022. There's a lot of comparison here. There's no real conclusion at the end, if that's what you're looking for. It's more just noting how the differences in time offer differences in data resolution, differences in data set, and a lot of similarities as far as how things actually looked, as far as how people were concerned. Some of the response was similar. In any case, we did have all the benefit of having satellites and having webcams and live cams and all of that, right? There were public outreach meetings that happened ahead of time. So all good practices, as we've been saying for a few months now, that'll help us towards the next eruption, because we really needed to bring this monitoring paradigm into the modern era for Mauna Loa and have a test run where no one actually was hurt, right? So people could have been, if it had gone differently, it could have been a whole different situation. Fortunately, it didn't. And that gives us a chance to work on that in the future. One little comparison I can highlight here that they actually have updated was the physical comparisons of those eruptions. So in 84, there were 58 billion gallons of lava erupted, covering an area of about 12,000 acres. In 2022, it was 40 billion gallons, covering an area of about 9,000 acres. So it says the volume and area covered was close to the average and median values for all historical Northeast Rift Mauna Loa eruptions. While it was spectacular, the 2022 eruption was ordinary. So fortunately, there were no impacted infrastructure in either eruption, 84 or 2022, and HVO is appreciating the community awareness and preparedness for eruptions, right? Which is where our mission is here, is that community awareness and preparedness for eruptions. So that's where we fit into the whole model here, and we'll keep doing that for that exact reason.
Yeah, really, it's the why it's so important is it's the first one we've had in 40 years, basically. Right, we haven't had the experience, so being able to see one in the modern era with all of our technology, we learned a lot, for the next one. So it's an important, it's very ordinary, but we didn't have ordinary experience type of thing recently.
Yeah, absolutely. Yeah, and the public got that view as well, right? And we actually got a baseline from which we can work and improve, right? Which is always welcome, right? It's hard to improve on when you don't know where you actually are,
right?
And so at least
it's hard to have that well captured version of what is normal type of thing to come back to,
right? So that is also on HawaiiTracker.com. Now you have to look back to last week's date for that, but it is up there as well. And we're caught up on Volcano Watch now. We can, of course, just touch base on Mauna Loa monitoring here. And I did want to, as I said at the top here, highlight this post by Raymond Nayart. So it was on the way to Kona on the 19th, and I noticed all the steam rising from the flow of Mauna Loa. So there it is. Cool. There's a Mauna Loa flow. Pretty cool. Yeah, people often wonder, where is it? And browser issues here. It's Facebook that's doing it. So if we lag, it's Facebook's fault. All right. So yeah, there you can see the path. There's that little branch at the top and that larger branch coming down. It's pretty cool to see that. And oh no, come on, Facebook. All right, so maybe it'll let me do this. I did notice here in the comments there was a video by Vicky Pruitt. Took a video at Four Corners this week, a 2018 flow near Kapoho. Let's see how big I can make this and show to you guys here. It's might be the best I can do here, but there you can see that even the 2018 flows still steaming, still hot by Kapoho by Four Corners, and stays hot for a long time when it's very thick, right? So here we are.
Right.
It's not quite 5 years, getting close to 5 years.
Yeah, it was an interesting interaction, kind of, where we had the people that from Kona side that were seeing this thing on the saddle, like all the steam coming off. They're like, "Oh my God, look at it!" And people from Lower Puna are like, "Yeah, that's what happens. So we drive through it every day," type of thing. Like,
where have you been? Not in Puna, right? So yeah, that's the most interesting thing happening there. That's the interesting exposure of the weather there. That's what I kind of started off saying, though. You don't always see the lava in these time periods, but obviously we've had plenty to talk about. We're at the end here of our hour, and there's the effects on Mauna Loa. I did want to make sure we cover the signals. There is a signal on Mauna Loa. You do see this little bit of deflection and a tilt as well. Mauna Loa, it wasn't rain, it was a bunch of snow up there, so maybe a slightly different signal, but here's the last month. See, the pattern had been an upwards one. Looks like you had a little bit of this downward deflection here, maybe the weight of the snow on the ground, something along those lines. That would be my first guess. But resuming its previous trend there as well. And here it is on GPS, still unchanged of its previous pattern. Note that it's still spreading and still rising, right? It hasn't risen up to the same level of where it was before the eruption began. It still has quite a ways to go, but it actually has spread back to getting close to where it was before the eruption. Up in here, yeah, when eruption first popped open here. So doesn't mean it's anywhere ready to go. It would take this signal and it rising up and all the earthquakes and everything else that we've saw in the lead up to 2022. We're not seeing any of that yet, so everything's still normal. Very few earthquakes this past week. 15 on this plot altogether. And we'll go back to the last month and get up to 120 or so, but that's really very few, and we're having hundreds per day in the build up to the eruption there. So really not a whole lot. And that's what the USGS update this week says. Right? From today, no active lava. Satellite imagery shows the entire flow field is cooling, no longer active. Everything's slow. Expected additional shallow seismicity and other signs and arrest and precede any future eruption if one were to occur. So nothing else new there. It's the same statement as before. And that is the Mauna Loa update. And I only have one piece of community update to share today, and that is the presentation on the 25th, on this coming Saturday, by scientist and comedian Ben Miller, who's been brought in by the National Park Service as an artist in residence for February. Right? So 11 a.m. to noon at Kahuku for free. If you can make it out there, that'd be awesome. Share it with everyone that you guys know. That's our community corner. And Dane, I'll pass it over to you.
All right. Well, I want to thank everybody for tuning out and turning in today. We rely on viewers like you to get this information out there. We don't have advertising budget, and really, it's all about the algorithms and stuff like that. And the best thing you can do is like, share, subscribe, comment after the video ends. All that really does help the channel, and we appreciate you guys. Also, want to thank the County of Hawaii for giving us the means and the funding in order to bring you these types of presentations continuously, as well as our written updates and everything that we were able to do on Hawaii Tracker. If you're not on Hawaii Tracker, hawaiitracker.com, the Hawaii Tracker Facebook group, check that out. That's where most of the action happens. hawaiitracker.com is more consolidated, just informational posts and things along those lines. The Hawaii Tracker community, though, on the Facebook's pretty big, and a lot of professional photographers in there that share their work and regularly. So definitely check that out.
Real quick, Dane. Yeah, I mean, there could be like we could do a whole video every week on just the photographs people submit. There's so many pictures and videos put on there. It shows you different aspects. We're just kind of pulling out what can be educational to share with you guys and make our point. It take way too long. So definitely check it out. There's a whole lot more really amazing stuff. A lot of things that I haven't shown that I have to cut out every single week.
All the rain coverage and videos and stuff like that, and looking at rain gauges of USGS, while the rain events going on. That's all on the Hawaii Tracker Facebook, right? While we don't really do that on the YouTube, this is more focused for the volcano, but Tracker itself is kind of wide.
Yeah.
All right. I also want to thank County of Hawaii, for that VI grant. I think I already went through that a little bit. We did have a super chat come through from our longtime supporter, Gary Bryan, who said, with $50, said, "Thanks, Phil and Dane, for these updates and deeper dive discussions. Appreciate the longtime support there, Gary." And I believe then with that, we can get into some Q&A. We have a couple here. All right. First one is from Paul, who asked, "So over the past 5 years, it seems that the Pahala hotspot, the earthquakes have increased in magnitude. Do we have any indication that this means for the future? Any future focus on those earthquakes?"
Yeah, that's a great question. We have noted that. We've shown a USGS graphs that have shown both the frequency of earthquakes, counts, and magnitudes. But there's not much more that we can say right now. We do have the one study that came out recently that was using artificial intelligence, machine learning out of the Caltech group that kind of mapped out those features deep near that upper hotspot transition into each volcanic conduit. There was a follow-up or kind of complementary study that was deployed last summer that we're waiting for results on as well. That will help kind of add to that story to help us at least see what it looks like down there. And then as far as the why, it seems like intuitively there's more magma coming from the hotspot up through the system, and it's not all going into Kilauea and Mauna Loa. It's kind of expanding this network, this pathway, this magmatic web, as it was called in the paper, right? That actually connects all the volcanoes down there. So that could also help you understand why Kilauea has been so active in the last over 10 years, right? And since the magma started coming back into it, and it might help you understand why Mauna Loa is active and erupting for the first time in 40 years potentially as well. It might be that the actual common denominator is the source from the hotspot down there is actually still very robust, still very healthy, coming up. Bigger earthquakes would mean larger areas of rock actually fracturing, so you're kind of building more pressure through there, and you don't ever have there's no documented pathway from the area straight to the surface. It's always through the existing pathways of the volcanoes that are already there. So the rumor that kind of comes up is, will it come up and erupt in Pahala? And the answer is pretty much no. That would be a huge shock and surprise everyone, and it would require to tunnel upwards through those 20 miles, and you'd have to see earthquakes coming up through that whole distance. And that kind of thing has happened elsewhere in the world, but why would it go through all that work when it already has pathways out, that it's already getting lava out through established things that have been there for centuries, right? So that's the possible future there, right? That's kind of our starting expectation, and when we see these studies, we can kind of adjust from there. So as the studies come out, we will focus on them more as well too. But we're very reliant on the seismologists and the USGS and other research teams to put that out. And it's not like the webcams where we can look at it and make our own observations in the style of Thomas Jagger 100 years ago. They just could not do that kind of study 100 years ago, right?
Yeah. Yeah, I think that answers it.
It's a good question.
Really interesting thing. There's also the research that is going to be coming out. I don't know exactly when, but in the future, that's ongoing with all the microseismometers that they've been deploying all around the area.
Right.
So there's definitely people working on it. It is an area of focus. It's just we don't have the answers right now on a lot of it. But yeah, definitely interesting. I do think the magma supply from depth right now is considerably high. Can't prove it, but that just with all the action, the Paul earthquakes, Mauna Loa, the inflation, the South Flank movement, and how flexible it is, it's like the supply's just got to be high. Like not like absurdly spectacularly high. It's just a high supply right now.
That was basic conclusion I had following the 2018 collapse, right? I mean, we thought after 2018, would the pattern change? Was it like a build-up burst that was relieved enough, or was it going to resume its prior activity? And so it resumed its prior activity pretty quickly, actually, and has continued to today. And that in itself is what's one of the biggest indicators of that very steady, sturdy supply rate of magma from depth in the hotspot. Right, so
yeah, everything points in that direction of a high supply. Nothing's really like pointing like, oh no, it's low actually. Like it just doesn't make sense.
Yeah. So yeah, I mean, and if it's happening that much pressure down there, then I would say that what that most likely indicates to me is it's likely to last a while, rather than kind of end next week or something like that, right?
All right, I've got a question here, another one from HD. I think this is a good one. So where did all the lava go from the deflation event? It's a fairly significant volume of the lake that just disappeared.
Yeah, it went back under the crust. It went back under the crust. There's a huge amount of lava down there, right? And when you have even some percent of it being dissolved gas bubbles, when you kind of can vent out the gas volume is usually what's lost. So that's the easy answer there, is when you usually see this loss in volume, almost always it's the gas is what you're losing. And sometimes you lose it in a more steadier rate where you don't really notice it. It's kind of bubbling out all the time. Eruption kind of stays steady for a while, but if it can actually separate and build up larger pockets of gas, however that may be, then if those build some pressure, that's what comes up as a large, big burst that causes a big effusive outputs. And when you relieve all that pressure all at once, then there's space underground for the lava to fill that area that was occupied by gas. Right? That's the easiest way to think of it there. That's, I don't know, complicated by the fact that whole crust that's covering a lava lake can also rise up and down, right? So there have been times where lava still injects underneath the crust, and the whole thing can still move up and down. And so it's not static, and that makes it complicated too. Right.
Especially when your depth reader is obfuscated by steam. It doesn't help. It doesn't help at all.
Yeah. Yeah, if we had those real fine measurements of the depth, we could actually say some more cool stuff, like maybe there's a gas causing this part of it or that, but we just don't have that. We have to wait for the USGS to filter it and publish those graphs separately for us.
Yep.
This is an easy Volcano Watch to write if someone wants to do it. Right?
Yeah, right.
Obviously, people are interested in the effects of rainfall on the lava, so we'll probably hear about this again.
Yep. All right. Well, I think that does it for questions for this week. We appreciate everybody tuning in. Make sure to like, subscribe, share, all that jazz. It really does help. Hate asking for it, but it's the game that we're playing. And we will be back next Thursday, 5 p.m. Hawaii Standard Time. That is our normal time that we go live, unless something happens. Don't really expect it, but hey, we've been surprised before, and we'll go live if something happens. And cover what as we can. Don't expect it again, but hey. All right, I think that does it for me this week. Appreciate it, everybody that tuned in. Appreciate it, Phil.
Thanks, Dan. Did we lag today? Did we have any?
No, we did. We got by without the giant lag spike that's been affecting us for like the past month. Like it did not happen.
I tried a few things extra here and we talked about, so like hopefully I'll keep doing those things here and we'll see what happens. Yeah.
All right.
I appreciate everybody tuning in this week. Everyone stay safe, stay warm, stay dry if you can. And until next week, from HawaiiTracker.com, he's Dane Dupont. I'm Philip Ong. Aloha, everyone.